Welcome to A-Level Computer Science. Firstly, we're going to talk about why you might choose to study computer science. The digital age needs computer scientists. Like it or not, this is the age that we live in. It's a digital age. We're all on our phones. We'll spend a lot of time on our computers. And computer programs have infiltrated every aspect of the way life exists at the moment. We simply don't have enough computer scientists around, and it's a job of growth for the future. They're needed in every single industry. You might think, it's just about programming computer games or programming programs for networks, etc. But actually, science, engineering, healthcare, we've seen recently, developments of apps in a short period of time. All of those things require computer scientists within the industry. 71% of all new jobs in STEM are computing jobs. So, nearly 3/4 of all new jobs in STEM are computing jobs. And 8% of STEM graduates are in computer science. So what you can see there is there's a huge gap in the market of available people to fill those kinds of roles. This is from the head of corporate affairs from Microsoft, obviously a huge software company and hardware company. It says, ask anyone who runs a business in IT where IT is central to products and services, and they will quickly mention the difficulty they find in getting the right people with the right digital skills. So it's hugely important for employers as well to have this level of people with the digital skills required to come from computer science. In the software industry alone, there's 20,000 graduate vacancies a year, and there are only 7,500 computer science graduates in total to fill them. So again, this highlights that there is a lot of jobs out there. So the next question is, are you able to study computer science? Are you suitable for the job? First thing is you need a genuine interest in computers, software, hardware, and networks. You don't have to have studied the course at A-level. It does help. But we will teach every aspect of it. If you haven't studied at A-level, GCSE, you do need to have a keen interest in programming. Okay, and if you're not sure if that's you, then either pop and see myself or Miss Lawson, and we will be able to advise you. Entry requirements GCSE computing are 4 or above if you took it, and a maths 5+ is preferable due to the nature of the mathematics within the course. What will be in the course? It's the OCR exam board. It's a 2-year linear course like most A-levels. All the topics, as you can see there, things like fundamentals of programming, data structures, algorithms, computer architecture, consequences of use of computing, etc. You can read all of those. At the bottom, you've got your practical programming project, which comes in your second year. And I'll explain the structure of how it's assessed in the next slide. A lot of these will build on a lot of things that you've done at GCSE, if you've done GCSE computing, and there is kind of a lot of building on the skills that you already have. Some of the programming languages that we look at, Python will be our main programming language, which you'll have a lot of experience if you've done it in GCSE, and also any of the Key Stage 3 ICT as well, like we use it at that level. C#, Haskell, we use a little bit of VB where we need to, some machine code, Little Man Computer, etc. are all examples of programming languages that we use. Just an overview of the content that you're going to see. So there's kind of a breakdown of 8 different areas, which you can see there on the left, which are normal areas of computing that you can use. 3 areas of assessment. So computer systems mark exam, which is 140 marks, 2 hours and 30 minutes. It's a written paper and 40%, and that will look at the top 5 of those content areas at the top. Then there's the algorithms and programming, that is elements of computational thinking, problem solving and programming, and then algorithms to solve problems and standard algorithms. And that again is 140 marks, 2 hours, 30 minutes, and it's a written paper. There is no programming paper specifically to do. And then have a programming project, which is 20% of the overall total, 70 marks, and it's done within class time. That covers all those areas of analysis of a problem, design the solution, developing a solution, and then evaluating. So it's essentially creating something for a company or a problem that exists. Some of the sample topics that you're going to see. So For example, where's data coming from every minute? What does that look like? How do we assess it? How do companies use it? All those kinds of things. So some of the things that are interesting: 72 hours of new video are uploaded to YouTube, 571 new websites every minute, more than 100 million new emails generated every minute. How can companies use this data? Where is it stored? How is it used? That's what big data is about. Encryption, so taking a message, encrypting it, sending it to the end user, decrypting it. How does that happen? What's the process that takes place? Another example would be this traveling salesman problem. So working out the shortest path, very much like an Amazon delivery driver. Okay, salesman must travel to all the cities at once before returning home. Distance between each city is given and is assumed to be the same in both directions. Only the links shown are to be used, and you've got to minimise the total travel distance to be travelled. And this can be done algorithmically. You could do it logically, and this is a type of abstract data type that we use. Some wider opportunities, trips to Bletchley Park, potentially, the National Museum of Computing. We do some cybersecurity challenges, programming challenges. Some of our students have done an EPQ project, and then that allows them to build on that when it comes to their Year 13 project as well. Some of students, we have some students who've gone to, some of the bigger universities, Oxford, St Andrews, Warwick, to go on to study computer science. And their EPQ link has been, something that they've really been able to talk about and excel with in their interviews. So as I said, a lot of people go on to study at university, but A-level computer science isn't normally a requirement for this. We've got past students working in these industries such as Microsoft, Google. We've sent some to some big universities, after some apprenticeships, working with, United Utilities, companies like that. So there's a lot of room for growth and development. The subject develops good problem solving skills and logical thinking, and is very well regarded by universities. So why pick computing? Because you prefer, this is what some students said, why did they pick computing? And I'll just let you read some of these. So as you can see from some of these quotes, you can see that very challenging course, but really enjoyable. The Times came with this quote as to why study computer science. Computer science graduates earn 5 times more than arts students, and students on tech courses can look forward to earning 5 times more than those with arts degrees from new universities. So it really is all about getting yourself into the job market and being able to make yourself marketable when you leave Christleton. If anyone has any questions, any concerns, whether you feel like you want to do the course, etc., then please don't hesitate to contact me on that email address below, and we look forward to seeing you all soon.